Assalamualaikum and hello everyone. Welcome to a new video for chapter 5, which is 5.2 liquid. And in this video, we're going to cover all the learning outcome for this subtopic. So we have 5 here, and then for 5.2 liquid, it is a lot of explanation, but I believe it's quite easy and simple because it is something that you have covered during your secondary school. Okay, so without further ado, let's look for the case of properties of liquid, which is shape and volume. So this is actually our liquid, and this is a diagram comparison lah, the arrangement of solid, liquid dengan gas. Okay, for the liquid itself, the particles are arranged closely but not rigidly. Sebab kalau kita comparekan dengan solid, solid, yes, it is close and it is rigid. Tapi kalau liquid, it does arrange closely but it's not rigid. Okay. It is held together by strong intermolecular forces, but not strong enough to hold the particles firmly in place. So, it's actually why does the arrangement of solid is like this is due to the strong intermolecular forces. Tapi it is not strong enough lah to hold the particle firmly in place, or it is in rigid position. Okay, so that's why for the liquid, the particles are able to move freely. Okay, and then, so contohnya kalau a liquid, contohnya kalau you pour over a cup, tak kisahlah cup tu saiz macam mana pun, bentuk macam mana pun, a liquid will always flow to fit the shape of its container. Okay, so that is for the shape and volume. Next is actually compressibility. Okay, compress. Compress tu maksudnya adalah, kat sini, ability to reduce in size. Reduce in size due to the pressure lah. Maknanya kita macam kita compresskan dia. Kita macam compress macam tu lah. Due to pressure. Okay. Again, for our liquid, the particles are able to move freely. But then liquids are much more harder to compress than gas. Because remember, kalau comparekan dengan gas ni kan memang able to move freely kan. Tapi liquid ni memang dia move freely, tapi at the same time, it is arranged closely. So that's why in liquid, the particles are packed closely and there is very little empty space, so cannot lah. So it is harder to compress kalau kita comparekan dengan kita punya gas. Okay, so that is for compressibility. Next is actually diffusion. So diffusion tu maksudnya adalah ability to spread out. Ability to spread out lah. Spread out. Okay. So for the diffusion ni, contohnya kalau kat sini lah, contohnya kalau kita letak sirap kita kan. Okay, so kenapa dia mampu to diffuse? Nanti once we put in a drop of syrup tu kan, adalah drop. Contohnya kalau, for example here, I'm just going to put a drop ataupun 2 drops of blue colored kan. Nanti lama-lama it will be diffused. Maknanya nanti all the solution itself ni will be blue in color. Okay, so again, in liquid, molecules are closely packed compared to our gas. Okay, and then for our liquid, it has lower kinetic energy than gas. So, bila dia lower kinetic energy than gas, sebenarnya dia akan ada stronger intermolecular force. Sebab again, kalau contohnya molecule tu dia move very fast, maknanya there is no attractive forces lah. So, kalau ada attractive forces, maknanya molecule ni akan attract dengan each other. So, dia gerak lambat sikit lah macam tu. Okay, so dekat sini, since it has a stronger intermolecular force between the molecule, so the diffusion rate of liquid is much more lower than our gas. So that is for diffusion. Okay, next kita akan tengok adalah viscosity, which is a tendency of a liquid to flow. Ataupun senang kita nak kata macam viscosity ni, macam kita comparekan our honey, madu. Kalau madu dengan just our mineral water. So kita akan katakan sebenarnya adalah honey is considered honey has a higher viscosity sebab dia likat kan. Okay. So, what is the factor concerning viscosity? First is actually about the size. Okay. So, for first one, okay, the size of the molecule. So, the bigger the size of the molecule, okay, the higher the resistance for the liquid to flow. Lagi susah lah dia nak flow. Okay, so it means that it will have the higher the viscosity. So, that is for the case of the size of the molecule. Okay, now what about our IMF? Okay. So, kalau kita the stronger the IMF, so maknanya the molecules are attracted to each other. So, kalau boleh dia tak nak move lah. So, bila dia tak nak move ataupun susah dia nak move, so it will have a higher viscosity. So, maknanya kat sini, the higher the viscosity. Okay, and then last but not least, kita akan tengok in terms of temperature. So, when the temperature increase, okay, so, it means that sufficient energy can overcome the strong IMF. So, bila strong IMF, sufficient energy can overcome the strong IMF. So, what happens is that the viscosity will decrease. Sebab remember, kalau viscosity ni kita nak strong intermolecular force lah. Tapi kalau ada energy yang mampu break the attraction, so the viscosity will decrease. Okay, and last but not least, we will look at the properties of liquid, which is surface tension. So, this is the amount of energy required to stretch the surface area of a liquid by unit area. Okay, so for example, if you have a cup of water, you fill to the brim, kamu isi penuh-penuh kan. Kalau kamu letak paper clip, it won't fall down. Dia memang kat situ je, dia tak akan jatuh to the bottom of your cup. This is due to the surface tension. Okay. So, sebenarnya, liquid molecule experience intermolecular attractive forces in all direction. So, contohnya kita tengoklah molekul yang number 1 ni. So, dekat sini, dia adanya attraction with the particle at the surface. Okay, ni, this is what we consider as surface lah kan. Okay. And then, besides that, besides adanya attraction between for the particles at the surface, dia pun ada attraction dengan particles within the liquid, dalam liquid itself. Satu at the surface, dan sama ada juga attraction dengan within the liquid. Okay, so the molecules at the surface are pulled downward and sideways from the neighbouring molecule. So sebab itulah kita nampak, so it's being pulled sideways kalau based upon yang kita punya surface ni. Kalau downwards, kalau kita punya yang molecule kita punya molecule in the liquid itself. So kalau kita tengok kan, molecule A ni it's actually yang ada neighbouring yang in the molecule sahaja kan, yang memang dalam kita punya liquid. Tapi kalau our molecule B ni, it is not only attraction between the gas molecule in the liquid, it also has attractive forces dengan molecule at the surface tension. At the surface tension pula, at the surface area ni sendiri. Okay, so kat sini so that's why lah we have our surface tension. So, kat sini we're going to mention that the stronger, okay, the higher the intermolecular force ataupun the stronger the attraction tu sendiri between the liquid molecule, okay, what would happen is that the higher the surface tension. Okay. Okay. However, kalau when temperature increase, dia lain pula. When temperature increase, what would happen is that the intermolecular forces will become weaker. Okay, kenapa? Sebab when temperature increase, kita akan increase the energy. So, what would happen is that we are able to break the attractive forces between the gas molecule lah. We able to overcome the attraction. So, that's why lah intermolecular forces become weaker. So, the surface tension will decrease. Okay, so that is actually for the properties of liquid. Next, we're going to look for the process of liquid itself. So, we know that for the case of states of matter, we're talking about actually solid, liquid and gas. So, next we're going to look for the process involving liquid. So, the first one is vaporization or evaporation. So, yang inilah sejatan penyejatan. Tak ingatlah bahasa Melayu dia. But what is actually vaporization? Vaporization is a process where our liquid will change to gas. Okay, so for vaporization ni, it will occur at the surface of the liquid. Okay. So what happens is that the molecule itself ni sebenarnya it move in rapid motion kan, where it will collide with one another. So for the each collision tu akan involve the transfer of energy. So bila molecule tu have enough energy to overcome the IMF, it will escape as vapor molecule. It will convert itself to gas. Sebab contohnya kalau dekat sini kan, it means that it needs a higher energy barulah dia boleh jadi gas. So for the molecule which receive the energy from the transfer from the collision tu, they are able to escape as vapor molecule. Okay, so that is for vaporization. Okay, macam mana pula dengan boiling? Okay, boiling pun sama juga, is a process changing from liquid to gas, but it occur at the surface as well as the inner part of a liquid, but it must be at specific temperature and pressure. So, yang inilah. Even though it's the same one, it will change from liquid to gas, tapi ada the differences tu. Okay, so I'm just gonna write down kat sini, kalau boiling, boiling, dia jadi dekat surface dengan inner, tapi specific temperature and pressure. Tapi kalau vaporization at inner only, any temperature and pressure. Okay, so that is the differences. Tapi dia akan change from our liquid to gas. Okay, next is actually we're going to define boiling point. So what is a boiling point? The boiling point is the temperature at which the vapor pressure of the liquid is equal to the external atmospheric pressure. So this is actually the definition. Okay, yang ini is actually a picture, an image. So you can see lah what is the difference between evaporation dengan boiling. Evaporation again occurs only at the surface, tapi boiling occur at surface dengan kita punya inner part of our liquid. Okay. So that is actually vaporization versus boiling. So sekarang ni kita nak tengok factors affecting vaporization rate. Vaporization ni, remember, from our liquid to our gas. The first one is IMF. So contohnya, if we have the higher the intermolecular force, maknanya the harder lah for the molecule to overcome the attractive forces. So it will be the lower the chances of the molecule to escape as vapor. Okay, remember, because kalau liquid ni, sebenarnya dah ada attractive forces kan between the gas molecule, between the liquid molecule. Kalau dia nak jadi gas, what we want is actually kita nak overcome the attractive forces, barulah dia boleh move like in random motion. Okay, so the higher the IMF, the harder for the molecule to overcome the attractive forces. So, tak naklah dia jadi, it won't become a gas. Okay, next one is surface area. So, what happen kalau untuk evaporation ni ataupun vaporization ni, okay, contohnya kalau kita ada, if you put it in the middle of the field, if you put a container with a high surface area dengan the one with a lower surface area, kita akan nampak that for the molecule with a high surface area ni, it will be faster lah for the molecule to evaporate, for the liquid to evaporate. Okay, why? Sebab dekat sini, the higher the surface area, sini padam jap. The higher the surface area, the higher the chances of the molecule to escape as vapor. So maknanya kalau dia besar, lagi senang lah dia nak escape as our vapor kalau compare kan dengan yang kecil. Okay, last but not least is about temperature. So yang ini, when the temperature increase, what will happen is that the kinetic energy pun akan increase. So what would happen is that, so bila the kinetic energy increase, so sebenarnya attractive forces between gas molecule ni, the intermolecular force tu can be overcome. Dia boleh overcome the force of attraction. So what will happen? More molecule will have energy to overcome the IMF. So lagi banyak lah the possibility, the chances of the molecule to escape as vapor pun increase. Okay, remember, so kalau nak from liquid to gas ni, okay, kalau boleh kita nak, satu memang higher chances lah. Kalau boleh kita nak overcome kita punya IMF. Sebab bila dah attractive forces between the molecule tu dah tak ada, so dia tak adalah held in motion. Dia tak adalah held closely ni. It won't be held closely. Dia akan move in rapid motion as in our gas molecule. Okay, so that's the factors affecting vaporization rate. So sekarang ni kita nak tengok. Okay, so here dia kata, molecule that escape from the surface of a liquid are referred to as vapor molecule. So that is what actually yang kita dah explain banyak tadi kan. Okay, in an open system, vapor molecule will evaporate off and diffuse away ataupun escape from the system. Sebab tu yang ni dia boleh escape terus lah. Tapi in a closed system, kalau vapor molecule ni leave the surface, they cannot escape from the system itself. Sebab this is actually our closed system, this is our open system. Sebab dia bolehlah diffuse away. Tapi kalau ni, dia escape our liquid, okay, leave the surface, tapi waktu yang sama kan close kan, so dia kena patah balik lah sianya, sedih dia. Okay. So, from here, in a closed container, kita akan belajar pula tentang vapor pressure. What is vapor pressure? Okay. So, in a closed container, the vapor molecule move in random motion and continually will strike wall of container, vapor molecule and surface. So, contohnya kalau kita tengok kan, so dia boleh move sesama, dia akan move in random motion. Dia boleh collide with each other. Contohnya dia boleh collide dengan wall of container dekat sini, and then dia boleh juga strike dekat surface of the liquid ni, macam ni. Okay, so but then every time the vapor molecule hit the wall of the container, pressure is exerted. Dia kata pressure exerted above the surface area of a liquid is called vapor pressure. So contohnya kalau ada collision above our surface area ni, yang dekat sini ni lah. This is what we call, kalau adanya collision tu, ataupun adanya collision which will produce pressure, di situlah kita akan panggil dia sebagai vapor pressure, yang above the surface area of our liquid. Okay, what is the relationship between the vapor molecule, vapor pressure and intermolecular force? So, when the IMF are weak, what will happen is that it is easier for the molecules to escape as vapor. Sebab bila dia strong, lagilah dia akan hold closely kan, lagilah dia nak jadi yang dapat yang macam ni. So, when it is easier for the molecule to escape as vapor, so bila banyak vapor, lagi high lah probability of collision between the vapor itself dengan dengan surface of liquid, dengan wall of container. Okay, so what will happen is that the vapor pressure akan increase. Okay, next is temperature. So, when the temperature increase, okay, the kinetic energy increase. So, what will happen? So, bila kinetic energy increase, it is easier lah for the liquid thing. From here, dia akan change into a gas. So, it is easier for the molecule to escape as vapor. So, bila bila the number of vapor is increasing, what will happen? Vapor pressure kita pun increase. Okay, so chapter 5.2 ni memang tak ada calculation, memang explain sahaja. Okay, last but not least, kita akan tengok is actually about condensation. Condensation is actually from our gas to liquid. Tadi kita banyak tengok liquid to gas kan? So, sekarang nak tengok gas to liquid. Okay, so macam mana gas ni boleh change to liquid? Okay, first condition is that during the collision, some of the gas molecule may lose their kinetic energy. So, when they lose their kinetic energy, okay, they do not have enough energy to remain as gas. Sebab kalau jadi gas, kinetic energy kena high lah sebab dia kan move around kan. Okay, so the gas molecule reach the surface of the liquid and trapped by the attractive forces. So, contohnya kalau dia dekat surface ni kan, surface of the liquid, contohnya pada gas kita ni, tiba dia dah sampai sini. Tapi sejak since it does not have enough kinetic energy kan, so they're being trapped lah. by the attractive forces of our liquid ni. So what happens is that the gas molecule turns into liquid molecules. Okay, so that's the first condition. Besides that, the condensation can also occur when the temperature of a gas is lowered. So what happens that, so bila temperature low, the kinetic energy will decrease. So, and it will move slowly. So, when it moves slowly, the attraction between the gas molecule ni pun akan increase. Sebab kalau dia move in rapid random motion, tak sempat nak rasa attraction apa-apa. Masing-masing duk nak collide with each other, collide dengan wall. Tapi kalau dia move slowly, adalah attraction between the gas tu is increasing. So what happens is that since it is attracted, so maknanya nanti pada sini where there is attraction, where there is no attraction, dah makin lama makin lambat. So when it moves slowly, dia akan the attraction tu increase. So what would happen? The gas molecule cannot overcome the force and turn into liquid. So dia jadi macam ni lah. From here akan jadi our liquid. Turn into liquid. Okay, so that's it. Itu sahaja untuk liquid kita.